Hello friends, this is Vinay BK. So today's session we'll be going to study about sequence networks of synchronous generator. That is sequence impedances and networks of synchronous generator. So or else you can call it as alternator. So here consider a three-phase equivalent circuit of a synchronous generator. I guess all of you know about the three-phase equivalent circuit diagram of synchronous generator. So consider this three-phase synchronous generator. So here the neutral of the generator is is grounded through a reactor say it as impedance Zn. Okay, current flows through the reactor or Zn is In. When a generator is delivering a balanced load, when generator is delivering a balanced load, which means that all the impedances are same if or under symmetrical fault conditions, the neutral current is zero. If all loads are balanced load, then neutral current is zero. That is Ia plus Ib plus Ic equals to zero. But when the generator is delivered or is delivering an unbalanced load or during unsymmetrical faults, neutral current inflows to neutral from ground via Zn. Neutral from ground. If there is unbalanced load, then current, that is In, which flows from neutral to ground, that is from here to here via Zn. Okay, so there are two conditions. When it is a balanced, then In is zero. If it is unbalanced, In flows from Zn to ground. Okay, here look at the EMFs, that is EA, EB, and EC are the induced EMFs of three phases. Similarly, IA, IB, and IC are the currents flowing in the lines. Current flowing in the lines when a fault takes place at machine terminals. Here we're not showing any faults in a equivalent circuit, but if the current which will be nothing but that flowing in the lines when a fault takes place at machine terminals. Since a synchronous machine is designed with symmetrical windings, it induces EMF of positive sequence only that we just discussed in a previous video. So the synchronous generator which generates only positive sequence voltages. There is no negative sequence voltage, there is no zero sequence voltage as well as current, that is as well as EMFs. So that we discussed in a previous video. Just if you'll be having doubt, you just check in a previous video how we are getting positive sequence EMF only. So now here just I'll be whatever we just discussed now. When a generator is delivering balanced load, symmetrical fault conditions, the neutral current is zero. If there is delivering unbalanced load, a neutral current which flows from neutral to ground via Zn. So now here consider this positive sequence. Instead of writing EA, EB, EC, I'll write here EA1, EB1, EC1. One represent positive sequence network. Similarly, Z1 is nothing but positive sequence impedance. All the impedances are same because the circuit is balanced. As I told, if the generator is delivering a balanced load under symmetrical fault conditions, the neutral current is zero. Okay, so look at here. Uh, Using the notation E for generated EMF, E is nothing but generated EMF, V is nothing but terminal voltages. We are just representing three phase equivalent circuit diagram into single phase circuit diagram. So if you want to represent the three phase into single phase, then what you have to do? The condition is that the circuit is balanced and will be having the phase sequence of 120 degree. That is a phase difference of 120 degree it should be having. So now here EA1, EB1, EC1 are the positive sequence generated voltages and Z1 is the positive sequence impedance. Because of the balanced and symmetrical nature of the system, three phase can be replaced by single phase. So here E is nothing but generated EMF, V is nothing but terminal voltage. So next, the equation that holds good for positive sequence network is just by applying KVL. Just by applying KVL, we can get VA1 equals to EA1 minus IA1 into Z1. You can write I1, B1, sorry, A1, B1, C1. You can take any one of the reference. So that instead of EA, I can write here VA1 is given by EA1 minus IA1 into Z1. So EA1, I can write EA1 equals to EA because as we discussed in a previous video, the synchronous generator generates only positive sequence voltage. So that is EA1 equals to EA. That derivations I was explained in a previous video. So that instead of EA1 I can write EA minus IA1 into Z1. Give this as equation number 1. Similarly for the negative sequence network model, so here negative sequence. So for the negative sequence, as I told, the synchronous generator generates only positive sequence voltage. There is no negative sequence voltage. So that a negative sequence induces voltages are not present in equivalent circuits, and also they are not generates in synchronous machine. We discussed in a previous video. So due to the fault or unbalanced load, the negative sequence currents can flow in the machine since negative sequence currents do not flow into the neutral. If there is unbalanced load, the current which flows to the ground. So here what happened? Due to a fault or an unbalanced load, negative sequence currents can flow in the machine since negative sequence currents do not flow in the neutral. So here Zn does not appear in the model. So again three phase into representation here. There is no voltage, there is no EA2, EB2, EC2, so that EB2, EC2, EA2 is a 0, so voltage is 0, so that you can represent it by short circuit. Okay, so that VA2 we can write here by applying KVL, VA2 equals to minus IA2 into Z2. It is known that the phase sequence of negative sequence current is opposite to that of the phase sequence of positive sequence current. With a flow of negative sequence currents in a stator, a rotating field is created which rotates in opposite direction to the positive sequence field, therefore at double synchronous speed with respect to the rotor. So here the negative sequence impedance presented by machine with this consideration is often defined as Z2. Z2 is nothing but negative sequence impedance. So positive sequence voltage we are getting of synchronous generator and negative sequence voltage we are getting. So coming for the zero sequence. So zero sequence, for the zero sequence, it is a zero sequence currents that flow in a neutral during an unbalanced or faulty condition. That is here neutral current is flowing in a neutral during fault conditions. The impedance offered by the synchronous generator to zero sequence currents depend on grounding of the neutral, that is of the star point, grounding of the neutral. So here IN is flowing, IN is nothing but uh, IA naught plus IB naught plus IC naught. All the currents are same, so that I can write 3 into IA naught or else 3 into IB naught or else 3 into IC naught. So IN is nothing but 3 into IA naught which is flows to the ground. So that here we'll be having 3 into Z naught, 3 into Zn, sorry, 3 into Zn from neutral to reference. So how we are getting this zero sequence voltage is nothing but here the current of 3A I naught. current of 3 ia naught produces a drop in impedance. So here the drop is nothing but 3 ia naught into Zn in the neutral impedance Zn. To show in a single phase equivalent zero sequence network the same drop when current ia naught flows, the impedance should be 3 into Zn. To get a zero same value of drop, the impedance should be 3 into Zn. So also here Zz naught is the per phase zero sequence impedance of machine and neutrally equivalent to the leakage reactance of the machine. So that the total zero sequence impedance of the machine, hence total zero sequence impedance is given by 3 into Zn plus the equivalent or else the zero sequence impedance. So that the zero sequence impedance Z0 is given by 3 into Z0, that is current flows to the neutral through the star point, plus generator impedance, that is ZZ0. Let's give this as equation number 3. Similarly here, when the star point is solidly grounded or else directly shorted to the ground, so if it is directly shorted to the ground is nothing but Zn is 0. So that system Z0 we can write here it as, if Zn is 0, Z0 we can get as infinite. So that Z0 we can write as 3 into Zn, 3 into 0 plus Zz0. So if it is solidly grounded, the zero sequence impedance, which is same as the impedance of generator, same as impedance of impedance of generator. When star point is grounded, when this is shorted, Z naught equals to Zz naught. Okay. When this is grounded, that is when this is grounded means when Zn equals to infinite, we can get Z naught as infinite value. Okay. So the zero sequence networks for a ungrounded generator is as shown here. This is for ungrounded and this is for grounded. Thank you.